Hello there, Reason people. PoohBear here, and welcome to my channel. I was just hearing that was the last project I actually put together, which I was talking about at the end of my last update. I've had quite a few major issues with this project, and hence why I didn't release it like I said I was going to. When I started to really scale up that project, my system really topped out at around about the 26 instruments. Quite funny. I mean, it was diabolical even to work in Reason without even running it. You know, you click on to say update a label and you type it in, and you could just wait 10 seconds for it to catch up. So when you moved a cable, you moved a cable and you had to wait for everything to catch up. It was just unusable, really. So in the end, I just dropped out 4 instruments only, and it started to work, and that was the result of from what you was actually listening to. It wasn't like a brilliant version of InC. I will put in the description below. You can download it. There's a WAV file, but it's 600 megs. There's an MP3 which is just over 100 megs. As I say, it's not a brilliant version of InC. However, from a technical point of view, you know, it's come from Reason. It was a success. So from one side a success, from the other side not so much a success. So today we're going to do a walkthrough of this project, and this is actually quite a new version. I've done quite a lot of changes to this one. The main issue I was really hitting on my old version is you had to run it in with a buffer size of 64, or you had to turn that option off to do with render using audio card settings, or whatever the one is under preferences. And that was obviously what was really killing my DSP. So I went back to the drawing board and worked out why did it really start to fade. I knew there was going to be timing issues, and yeah, I found a very interesting. I'm not going to use the word bug, but I obviously introduced the bug, I suppose, effectively. And I've got a real cool workaround, but it has meant I'm literally rebuilding this project sort of from scratch. It doesn't actually take that long once you ironed all the little bits out, and then, yeah, it's a case of piecing things together. So, you know, i.e. for me to add, this is going to be an 8 instrument project, and this is going to be uploaded, ready for you to download as you're watching this video. So you can go and grab that, and you can start playing with it and add your own instruments. But I thought, right, let's do a quick high-level overview of everything so you know what to do and what not to touch and what to touch. And I'll also talk about some of the other more recent issues I've sort of come across and had to resolve. I'm still quite lucky that the only 2 paid devices are the dual CV source and also sequences by Robotic Bean. So everything else should be free, I believe. I hope I haven't added anything funny in there, and obviously it's going to come down to what instruments you really want to add to it. Yeah, this over here is just there for a little bit of fun. This is the proper on-off button to actually start and stop it. I found this to be quite nondescript, which in a way was quite nice, that this had all the power to start the whole project off, to kick InC off. I found that quite nice, but at the same time I wasn't too happy with it, and really I was nearly going to reach out to some devs and say, look, can you just quickly knock me up a nice big button? I would have preferred to have something like like a big nuclear bomb button that we can press and get everything kicked off. So in the end, this is obviously an audio device, and I just took the audio, took the signal, turn it into CV and manipulate it a little bit so I can turn that, and that would actually turn my main start on and off. So I just thought that was just there for a bit of fun. So as we're talking about the start area, this is the true start area. There's a -1 when it's off, and it's 1 volt which is being sent through, which goes off and kicks loads of things off. And we'll talk about that in a bit more detail because what I'm going to do, once I've done this first bit of walkthrough, I'm going to actually load up a brand new instrument and wire it in. You can see how it's all wired in. Important things though for you would be the times length. This is done, you give it in negative numbers. Again, it just saved me doing another step further down to convert it all back, and I thought, well, because I'm trying to keep this project as streamlined as possible. So you work in negative numbers, and basically a 1 is effectively 8 bars. it shouldn't go any smaller than a 1 because obviously phrase number 35 is 8 bars. I've been having this set at 4 and been getting some interesting results. I've only got it down for 1 because obviously I'm still doing some testing and I don't want to wait the equivalent of whatever it is, 32 bars or whatever, before it decides if it's going to move on or not. So that's the only reason I've got that down. The other one which is worth keeping an eye on is this attack. I call it attack because I'm actually, on most instruments, I'm affecting the attack on the janitor. On this particular janitor only, I'm actually affecting the decay because I've got things reversed around. And we want this as low as possible. I've been running this at around about 0.03. I've had to up it because obviously I've moved into my DX drivers now. I do have rendering on, so I am using the DX equivalent buffer size, but you know, my DX drivers are very flaky, and so I had to up that. So basically, the larger the buffer size you have, you may have to raise the attack. I have found by having it on 0.2, 0.3, I'm sure I tested it up to a 1K buffer size and it was still okay. Or was it on a 1K? God, I've done so much testing, I'm losing track. Definitely on a 2K buffer size. 2K buffer size, for some reason, you really have to start ramping stuff up. And this is all to do with the timing, and I will go into a lot more detail about what that really is doing when we start to load up some of this other stuff, because it makes much more sense. So obviously over here, these are all constant values basically at the end of the day. So rather than me having like loads of these all over the place, I've got my main constants. I've got them all going through some splitters and all the rest of it. He says I should be able to switch around to the back. Am I on the wrong screen? I probably am. Let's bring my mouse over there. Then will that work? Yeah, that works now. So yeah, so you can see I'm just splitting it all out, and because these are constant values, it doesn't matter that I've daisy chained these together. If you've seen my other videos, you know I don't like to daisy chain things together, and over here you can actually see I haven't actually daisy chained them together. I've used a splitter at the top, signals in here, and I've used this to split it out, and then they go to their individual ones, whereas over here I've got a signal coming in here and that goes to there, then that one goes to there, then that one's going over to there. So I'm splitting them that way. Because these are constant value, it doesn't matter if there's a delay in the CV signal because you're delaying the same signal, so it's never changing, so it's not an issue. Over here, it's a lot more important because obviously we want everything starting at the same time. Spiders are very special. Obviously they've been around since Reason 1, and the reason they're very special is if I was to put my latency monitor here and daisy chain between them, you get 0 latency. There is no latency daisy chaining. As soon as you daisy chain from here to here and you put your signal here and here, my latency monitor, I will see whatever my buffer size is, that's what I'm going to see as my delay. And obviously if I go over here, I get 2 lots of buffer size delays. And these are some of the issues which I've been really trying to resolve. And as I say, if you work in a buffer size of 64, I think Reason, and there's a good chance I was doing a lot of my project originally with the rendering turned off because I sort of flip in and out of videos or whatever, and it's a way I can get I know I can guarantee I get myself a 64 buffer size, and I think Reason actually works in a slightly different way as well. And we're going to details because obviously that's how I had to sort some big issues out to do with timing and the buffer sizes. So constant values over here, big start over here. Next little lump down here is my injection system. And basically all this injection system really is doing, it's kicked off when you very first start the project, and it gives a stagger start to everyone. So everyone should start coming in at different times. So this really tries to split the stagger start up a lot more. I am going to be doing it, I'm not on the project that you'll be getting, but going forward, I'm just going to work out when we're on the very last step to try and stagger it out. I've had quite a few successes where it staggers out on itself, on its own, and then others it doesn't. The project's got a bit of a, well, I suppose because it's so randomised, it really does have a life of its own sometimes, or how it sort of works. Sometimes it keeps all the phrases very close together all the way through, and other times it might leave one really far behind, and then we get this buffering at the end. But I'll talk about that when we start getting into this area. So that's all that injection system is. And you can manually kick it off, and I've only doing it for testing. So I'm going to leave this hammered in there, and for testing only, this button here will actually kick off this. Can we get it all on the screen? Oh, see, I don't forget I work on a nice big screen, so I get absolutely everything. So when I click that, it's going through all the different instruments. So, okay, we haven't got 127 instruments. This is set up to obviously to do 127 instruments. You're never going to get 127 instruments to work. I'm not saying because I've got quite a good system. The fact I bottomed out at 26, I'm not saying your system won't go higher. But to be honest, I found like with that, you can hear it, as I say, you can download it and listen to yourself. I actually think less is a lot better in this project with the sounds that we're using over, I suppose, if you had real instruments, because obviously if you've got real instruments, you've got a lot more feeling you can do with them instruments. There is still work to be done overall to this project. One of the big things I was going to look at, because I was going to look at the velocity data and how can I sort of give a wave effect going on, say, with the velocity data, so we can have some instruments a little bit louder in parts and let it go loud and quiet. And I think I'm actually going to do it at this end. So I'm going to forget the MIDI side and the velocity side, and I'm just going to sort of raise and lower the volumes, obviously using LFOs and the other thought I did have, and it'd be an experiment I'll probably do, is I might add 16 instruments, but only actually have 8 playing at the time and pair them up and have a crossfader between the two. So we can just sort of crossfade 2 in and out. That might give an interesting result, but as I say, that's further down the line, and I will be obviously looking at that, and obviously I will release that once I get that done. So that's just the injection system. You don't really have to touch anything in there. This is the main pulse, so obviously it's the pulse actually, which is the piano, which is playing the 8th note throughout, but it's also the main pulse which is driving all the counters and to keep all the counters in time. Yes, when we run this project, you should run it with the transport bar on to make sure all the LFOs, because they're tempo sync, will all be then kept in sync. But there's absolutely zero obviously data at all in the sequencer, because there's nothing going on here, it's all going on elsewhere. So yeah, so that's the main pulse area. So let's go back to the top, I think, over here, because this is where the exciting stuff. So we just talked about the consonants. Now this is a real kind of interesting area. Well, I found it interesting, especially when I was putting this together, because this really works out where an instrument is in relationship to other instruments, and it's not like the exact position. It's more to the point is, am I lagging or way behind, or am I right up in front? It gives them that kind of detail. It was quite hard to sort of try and work things out, and then I came across this device, and this is quite a good device, the mod cell saw. So it's a select, and it's also a sensor thing. It's just sort of merged that name, but it's an interesting device because it gives you the highest output. So you can obviously put loads of stuff into it, and it'll give you your highest output. Now, you notice this says lowest here. I wanted to find out what my lowest instrument was. There isn't an equivalent for the lowest one, but it's quite straightforward to actually do. In the end, I just took my signal and I inverted it. So I invert all the signals, bring them in, so now they're all negative. So now the lowest one will effectively be the highest one. However, with this device, if I unplugged that middle one there, say like number 5, it will stop. This will stop working. On this one down here, which is doing the highest, if I was to plug on number 5, it will still work. What seems to happen is, if you have got a gap and you've got other things plugged in, the gap seems to be, I think that's sending out a 0 signal. So because I'm negative, well, a 0 signal is higher than a negative number, and that's why this fails. But down here it works because I've got the highest number, so obviously I'm in positive numbers, so it doesn't matter the fact that there's a 0, because I'm actually got stuff higher going on. But it's something which caught me out. mainly because when I sort of ramped this right up to loads of instruments, I thought, oh, I can just willy-nilly delete whatever instruments I want out. No, you can't. So if, as I say, I'm going to upload this one, which is going to be an 8 instrument stack, I'm going to do another one, which is 16, and I'm going to go for probably a 24, and I might even try and push again for a 32 if my system works this time, because now I've resolved the rendering, the buffer size issue. So if you was using, say, the 16 one, you think, oh, my system is struggling a bit, I need to delete a few instruments. Well, you have to make sure you delete instrument number 16, then 15, 14, 13. Obviously, you can delete all 13, 14, 15, 16. You have to do it in that order, but just make sure you delete the higher ones first and come down. So that's quite an important thing. We've got all kinds of things going on here. If you notice, it says the lowest real, because this is the real lowest number which comes out here, and then we've got ourselves a fake one, lowest fake. What this one does is I take the signal all the way through and I do a few calculations and I bring it back in, and what has to happen is in C is when you get to phrase number 53, you all wait there until everyone catches up, and then you all fade out. You all stop in different times. And the way I actually did it was I created so each of my phrases, I think I call them counters, so you might hear me talk about counters and counter 2, 3, but counters are also the phrase numbers, phrase 1, 2, 3, and all the rest of it. So I've actually put an equivalent of a phrase 50 or counter 50 into here, because this is looking for the lowest. Well, counter 50 is way down the stack, so that input signal doesn't take effect until everyone's got to at least counter 50 and started going over counter 50. And what this does is when everyone gets to 53, I've got my blocking, and this does the blocking as well, so it will block the signal. So if an instrument goes more than 3 phrases in front, so there's a difference, 4 phrases could be playing. So if you've gone 3 phrases in front, you get blocked. This one gets blocked and can't go any further until this one moves on. And that's effectively, and I've used that blocking mechanism to stop everyone to get onto 53 until the last instrument's got onto 53. Then I know everyone's on 53. And what I've actually done is, once everyone's on 53, there is actually a counter 54, which is really phrase 53 again. And the reason I did that, and it's not been in this version, is I thought I'll open it up and then everyone's going to, because there's a good chance that everybody or a number of people could be at the end of their counter on phrase 53, waiting to stop, and you might have had a new one come in, and they all kind of stop quite quickly. I've had other ones where they really do stop over a period of time. But my feeling was, well, if I have an extra block, I can push everyone over into that block, and just like I do at the start, I could inject. So this injection system, as I say, it doesn't stagger start. Again, it should give a more of a staggered finish as well. That was a theory. I haven't tested it. It's quite a solid theory, to be honest with you. As I said, I was playing some, and they did all stop across time, which I thought, okay, maybe I don't need that. But I think there's some cases that I may need that, and that's something maybe I might be able to build into this logic, but we'll see. So that's what that's doing. It's working out if you're the lowest number, the highest number, and then from there I can work out, do I need to block myself? Also, you know, we got this one what's saying, oh, I'm going to be blocking, and a little bit later on you'll see I'll be talking about this as well. Well, if this one's way back here, because we've got this, there's a randomization process to say, oh, can I move on to my next step? Well, because it's so far behind, I've done a calculation to say, well, actually, I use a lot of weighted randomization processes in this system, and they're very heavily weighted to say not to move on to your next step. So it really hits it very rarely. Well, if you're lagging, it changes the weights so you hit that step more often to say, yes, you can go, you can go, you can go. So hopefully this one will start to catch up a little bit. And it allows obviously the song to progress on and through. So that's what that's all doing. I know there's a lot of wires and things, but that's the main job of that. And then this is the final bit down here. It's not that one, is it? This will just be one of these. It's just a little LFO, which is doing the randomization. I'm not happy with this randomization at this moment in time. It seems that maybe there's the algorithm behind this randomization, or they're using very similar seeds to do the randomization. Because what I've been finding is they do change pretty close together. As I say, because they're so weighted, that they're going way over their time length, and I'll talk about time length in a minute. I did at the beginning. That's, as I said, that's the -1, the 8 bars. So once it's finished that, this timer then starts to kick in and it goes on. So in a lot of cases, it'll double it. So you'll be actually doubling your length because this is so weighted. And then it'll say, okay, you can go. But I found it also lets the other instruments go really, really quickly behind it. It's not exactly the same time, but it is so quickly behind it. It's a little bit confusing that, you know, are they using different algorithms? We've got, obviously, there's 4 lots of these because obviously each, I've got 2 little LFOs per combinator, and we've got 4 combinators, which will eventually give us 32 instruments. Once I get my next lot of 16 out, it's going to be interesting to see if there's a difference. Well, there shouldn't be a difference. The first 4, and I've got a second 4. That's how this is split, 4 and 4, because obviously there's 4 LFOs and 4 LFOs. So maybe I'm going to have a closer look at that and see if there's a difference between these two, because they're coming from different machines, and if they're using any kind of different seeding. Yeah, that would be one to look at. Anyway, and obviously if they're using different seedings, then I might have to do something a bit different to give a bit more random LFO. So that's just the basics of this main side, what you're going to see. And then over the other side, which we're going to do in a minute, we have all our different instruments, which work out which pattern am I going to play. It's got the counter in it to count down, which is driven by the pulse. Works out if the blocking needs to be done or not. And also, as I said, here I take, if I'm so far behind, because these have all got numbers, I can take that number, times it by 10, and then I grab that number, pass it down to my little LFO to change the weight system to allow it to go through, and my counterfix. So let's actually have a quick butchers at that stuff. So I'm going to do it over, so I'm going to do it in this middle part here. This is where I like to do my stacks. So I'm going to need my main combinator, and I'm also going to grab my counterfix. So let me hold the shift key down when I create this, because this is just my fix, and I always wire bits of this up first, and then I'd wire it into there. And as I say, on my big screen, this is 100 times easier to wire up. So originally the start went off to loads of other AB switches and started that. So no, what I'm going to do now, I actually fire off something into here. So this is number 8, so I'm just going to park it in to get a start. What that does, I've got these flushers. I've called them a flusher, my CVA 7. So let me first of all just do a couple of things here, and then we'll come back and talk about this. So this is my attack time. So remember I said about I needed to get my attack time. So there's my attack time offset. So I'm going to plug that into there. So that one's done as well. And then the rest of it I need to actually wire into my main device. So now I'm going to take this device, park it here, and I can open up this one here. And in fact, as I go along, I've got to make sure I put the instrument number in. So we're on number 8, and in fact I should make sure this is number 8 as well. God, I'm not usually this organized. So I've got it quite labeled out of what's what and what's going on. And most of these labels, especially with the asterisks, they're actually more for me to say, right, once I've dropped an instrument in, these are all the the bits I have to wire up outside of this combinator. It's such a shame I couldn't have this stuff in this combinator. The only way I could do it is if I took over the mod and the pitch wheel, which is, you know, doable. The only issue there is if you change your instrument, you have to go back to the instrument inside the combinator and actually disable the mod and the pitch wheel to it. If not, whatever we're doing will have effect on the instrument. It's a real pain there. It's a shame you can't say, well, this instrument, I don't want the instrument ever to respond to mod and pitch wheel. But I say, change your instrument and it will. Change your patch, you're okay, but change your instrument and it will. So let's actually talk about the counter and the real issue with the counter and what was happening with the counter and my workaround. So this is obviously analog in a digital world. So we're playing analog in the digital world, but we've still got to remember that we've got to apply digital rules, even though we're looking or we think about analog signals. It becomes quite a nightmare when you sort of do this stuff. So as I said before, this spider is a bit special in a way that you can put a signal in here and it will push it all the way through the system and out. But I've got my counter, so let's start with the first loop actually, and there's a little bit of missing and I'll bring that in a second and you'll see what's going to happen. So my loop's going to come in and let's say I've got myself 0 volts going through the system and I'm looping back and I've got 0 volts. Brilliant. I've got this injector going into this. So I've got this injector and I can't see it, I'm being blind. That'll be that one there, sorry. This is my injector one coming in here. So this is actually going to add 1 to this, or it's not really 1 volt, it's actually 0.008, I think that's what volts I'm adding into this, but let's just call it 1 for simple sakes. So it adds 1 into this and 1 starts going around the system. Well, this is, as I said, because this is digital, in the digital world, and I've explained this before in other videos, you've got to pass a 0 around. So even though you're not passing, you think you've got 0 volts. So in the analog world, 0 volts really is no voltage. I have 0 apples in my hand. Yeah, you can't see them. In the computer though, to say you've got 0 apples, you have to store a 0 somewhere. So a 0 has to be stored in the computer to say you've got no apples. And the same applies with CV. So I've got a 1 coming down here, but I've also got a 0 looping back on itself. So in the let's say buffer size 64, you didn't see this. You really didn't, you know, if it was happening, it's happening at a speed, or maybe it was happening in a way, I don't know. I haven't got a proper answer for you, I'm afraid to say. I can't crack open the reason code and really look at it, but it definitely manifests its head when you start to go above the 64 buffer size. And so the 1's coming along here, the 0's coming on here, so it pushes the 1 out, but it's pushed a 0 in. And so the timers, even though I had my timers sort of working, I could see them flickering up and down, they was doing bizarre things, so the timing is obviously very critical, and on some cases I did see the timer just block, it just stopped, it wasn't counting down, it should have been counting down. And in fact, I had a number of these dual source, and I could see a little flicker. The number wasn't flickering, but I could see this that has on the front. Sorry, let me switch around. It has like these little counters and things, and I could see this flickering. So I knew things were going on with it. So the workaround was actually, it took me quite a while to figure this out. I even spent a day contemplating and loading up and looking at could I do something with, well, create myself something actually. That's what I was actually looking at. So I'm just going to move my camera just a wee bit. Oh, I can't move it that way and I can't move it that way. Just see. Oh, I don't like that corner bit. Anyway. Yeah, so I was even loading up the, to do actually see if I could make something. God, how silly of me. But it was a nightmare to go through. So the final solution I came up with, and this is really what my fix is over here, is I come down, I inject my new signal, a 1, so the rest of the signal is a 0, which is going around the rest of the system, and I come into my CVA. Bosh, I'm now into my CVA. The CVA has a really lovely feature on it. Obviously it shows you min and max times as well as your current version. We can take the max value out. So I'm now going to take my max value out and I'm going to put it into my splitter here. So now I'm pushing 1 in. I've still got a 0 coming around this side and that one's gone out. And then the 0 does come back down. And by the way, all my logic for driving stuff is after this split point. So I drive everything after here. And this is only my injection where I count it up. So the 0's come along here, gone into some CVA, and my CVA looks at it and goes, well, I've got a 1, you're a 0. So I'm going to throw you away and I'm going to carry on pushing the 1 through. So we've got around that issue. And that's why I called it a flusher, because I thought of it as a pipe with a bit of air in it, that the air's going around, and when it gets to the CVA, it squeezes that bit of air out. And so we've got ourselves a real solid signal all the time. And as I say, none of this stuff this side gets affected because, as I say, that's only the injection side. So this side does go to 0 for a little brief moment, and then it'll catch up with 1. But that doesn't matter. It doesn't affect it of what we're doing. And that took quite a while to eventually get this working. Now the big issue, and it is a nasty issue, with the CVA is there's no reset CV in, so you have to use the combinator, and hence why I needed 2 extra ports to hit this reset. The other issue is the reset or the combinator has to have a signal going in for it for a long time. There's a lot of stuff we can trigger over here in these switches with a really, really tight trigger. But we need such a longer trigger over here, and because I've got quite short triggers going on, which are going back and forth, when I get to here, this is what that attack was all about. It basically allows something to go up, and I know it says attack and all the rest of it. Because I'm taking a negative figure off, it's the way it works, the opposite side. Yeah, so it makes my trigger now a little bit longer coming down, and because the combinator, if you think about it, a combinator needs a 0.5 of a volt and it'll start to do something, and a negative, it turns it the opposite way. So obviously I can give that a bit of an attack time and allow the reset button to be properly held down long enough to reset. The difference between these two, this janitor's only driving this reset down here. The reason this doesn't have a reset is because this is the one which is started with our start, with our nice big button over there. And we're stopping it manually. So we're stopping and starting this manually because this is the counter purely for what phrase are we doing. Whereas this one is actually obviously getting fired off every 1/16th, or was it 1/8? 1/16th, 1/8. 1/8. I'm going to go with 1/8. My final answer, 1/8. That's my pulse. Yeah, it's going to be it's the pulse. Yes, it's going to be a 1/8. Yeah, so I had to reset this one, and that's what all this gubbins here is really doing. So let me flip round, and before I get too lost, I better make sure I'm just going to quickly wire up the other two. So this is my other counter. So I'm just going to wire these in while I remember. And as it tells, I've got to get a delay from the signal, and that delay signal is the fact that, oh, got it. It's quite weird the way, it's quite mind-blowing the way this works. This is the real pulse, which is pulsing down, which opens up the gate, and that's basically, have I finished all my time lengths? Yes, that gate opens up, then goes down to my LFO. My LFO will say, am I ready to go, ready to go, ready to go? Then that will say yes, then I come down to my blocker. Where's my blocker? So that's another AB switch, he says, which you'll be able to see from the front. Yep, here it is. And my blocking, and actually it's down for blocking at the moment, which is probably a good possibility, because I've got things whizzing off. So then it won't go past there. But then if it does go past there, he says, God, whoops, that's not the blocker, it's that one there, isn't it? Yeah. So then once it's gone past there, I've got this false signal, which is then going back up to the top to trigger this to move you on to your next phrase. Oh, God, we've got there. And because it's triggered that onto the next phrase, then the counter's going down again. And it's quite a, this in itself is a massive loop. So we've got ourselves a big loop and we've got some delays at the bottom. So as I say, that's the main countdown for the time length, which is doing there. I've just spoken about that. This is obviously an interesting area because this is where I take what phrase I'm on, and actually we're going to wire that up in a second, and I'll show you how that all works. So let me just do a quick count up. 1, 2, 2, 2. Brilliant. So that's all done. So I can actually take this and I'm just going to park it right down the bottom out the way, because that's what I do, which means I can bring these two more onto the screen because I need to wire the rest of this combinator up. So I need to get a pulse for my main countdown timer. So we go over to the pulse. As I say, if I was on a big screen, I don't do any scrolling whatsoever. I can just do this really nicely. And then the next thing, we need an injection from the merger. So let's go and find my injection, which is going to be number 8 in this particular case. A lot of the things which I'm wiring in over this side don't matter. The only one which ever makes a big difference on anything is to do with the LFO. So the ports and that I'm using for everything over here and here and there doesn't make a big difference. Obviously I'm going to wire these up in order, as I said, because if you don't delete in the correct order, you're going to find yourself in a bit of trouble. So that's my injection system coming in, as I say. So my very first pattern, I've got injection, staggered start. Then it tells me this is my merge in for my offsets, and this is to do with the times and the length. So, that's the other big difference I've done with my counters as well. Now I've introduced I have got a counter which counts up, counts down, and you can offset, you can do all kinds of things with it, and it's quite a biggish combinator. I'd release it so you can have a play with it. But there's a lot of times you can actually just have a simple counter counting up, and from that counter up, you can actually turn it into equivalent of a downwards counter. You can say, well, actually, even though I'm counting from 0 up to 10, well, I could have that as equivalent of 50 to 60, and you could do the negative. And this is really what this part of all this offset is actually doing. I'm taking the original, so there's counter up, but I'm actually taking it and I'm inverting the signal, and I'm adding the original signal to it. So you're actually, you can do all kinds of things, I say, with the counter. So it's like effectively just reverse the counter and doing all, and yeah, it works great. And by counting up from a 0, I can hit the reset on the CVA, and the CVA then sends a 0 absolutely everywhere, because I did have it that I had an AB switch, and the AB switch, I don't know if I ever spoke about that or not. Oh, I did, I've done a counter video, didn't I? So in the AB switch and the counter video, it would actually have what the true reset value would be. So the time length would be coming into this, and then I'd switch it. But then with using the CVA, the timing was so precise that I had to hit my reset switch. I had to then flip this switch. I had to hold this switch down long enough that when I released this button, it took the new value in for me to turn this back to start things flowing again. So going from a 0, it's 100 times easier, and then do all your offsetting afterwards. And I just find that so much easier to do. And I will highly recommend doing your counters that way. So right, I've done my merging for there, I've got my injection, so I need a constant value of 1, so I've got sort of 1 over here, so let's grab that. So this 1 is what goes actually through all the system. So at the moment, everything will be looking at probably B's. So let's have a look. So everything on the closed is a 0. The same with the weight, and the blocking as well is the same. So when I've got an open, I'm going to send a full volt through down to the next stage. And the next stage is basically doing something very, very, very similar, to be perfectly honest with you. It's taken my 1 as an input, so my 1's come down here, now my 1's in here. Again, it's going to work out from the LFO, can I move on? Yes, I can move on, so then it's going to push another 1 out and to the blocker, and can I go through the blocker? Yep, yep, yep. And then eventually, as I say, we go back to the top and we trigger that LFO. So it's that 1 which ends up triggering, sorry, not an LFO, the dual CV source. So it's the 1 that ends up triggering that, which then starts the whole loop off all again. So I put my 1 in down here. This is my weight control. Hang on, let me put a K on here, and then we can get rid of a lot of these wires, he says. There we go. So I need to take this control out here, and it goes into my LFO weight down here, and it'd be this one down here. As I'm down here, I'm just going to collapse that down because I like to keep things in order, and then I'm going to take this merger, and this merger is going into this device. So that's for my weight. So what's happening down here is, let me go and set this up as well from the highest. So this is my highest split. So I was going to bung that in there quickly. So I'm finding out the highest number. I know what number phrase I'm on. So this is the highest phrase. I know what phrase I'm on. I can add these kind of together. And in fact, I'm doing an invert, so I'm actually taking mine off that one. So if we're the same, it becomes a 0. If I'm lagging, I get myself a number. That number I'm timesing by 10 because they're very small numbers we're dealing with, because we're only dealing with very, very small voltage. And then I can invert that, and that goes out down to my weighted system and moves my weights down, which gives me more chance to move on to my next phrase. Oh, such a mouthful. Don't have to do anything with my blocker, and that's probably why I always tend to have that hidden. So from here, right, merge in from the lowest split, so that's my lowest split. So I always, don't know, ask me why, I always go for my B first rather than my A, because that's going to go into my lowest at the top, up here, so that's quite an important one, that they're in order. And then I'm going to take, and so this is invert, so I take what counter am I on, or what phrase am I on, I invert it, so that's giving me the reverse. So it's now obviously minus figures, which I said to you, because we inverted it, the lowest one, this now works on the lowest one, and obviously I'm taking a non-inverted one, putting it in, and that's going to give me the highest value which is available, and we can do our calculations. And that's it really, he says. Final thing to do is we've got to put ourselves an instrument up. I've been playing around with a few sounds, so have I used that one? Oh, I don't know what I've used and what I haven't, where I left myself. So let's quickly drag over here and have a quick look at number 7 and see what number 7's got in the bottom. Ah, so that's that one. So, okay, I will go for that harp drone pad then. Sound-wise, obviously, totally down to you, what you choose. I do think having some, as I say, some very slow attack sounds, which I haven't got at the moment, but having some very slow attack sounds, you won't hear them in a lot of the really quick phrases, which is absolute phrases, which is correct. Then on the slower ones, they're going to really come through, and you're going to get some nice sounds coming through. Yeah, So yeah, totally down to you what you really wish. Oh no, I wasn't on the right instrument there, was I? Let me Control Z that. Let's put that back to, that's my number one. This is the one I needed. So I wanted that one into here. And did I turn this down? I have turned it down, but obviously I need to, did I drag that across? No, I didn't. I haven't turned it down either, so I can do both at the same time. So I have grouping turned off, so obviously I can move everything around separately. And this probably needs to be panned somewhere, I don't know. And needs a bit more as well. Obviously you need to sort your levels out and all that sort of thing. As a test, what I can do is come over here and just turn this on. About the level I want. Oh yeah. Put that down to a 0. And turn your slave on and off, it definitely puts it back into slave mode. So obviously when you do change it, you're not quite in slave mode, even though it says slave. So I turn it on and off and I'm definitely in slave mode because that pops up. What I've done is I've bussed up all my channels, and that bus I've record source, and I've got myself an audio track so you can record your sessions. So it's just a simple case of coming in and just recording, and you can record your session. Do not save this file with a recorded session, or I highly recommend you don't save a file with a recorded session. Just bounce it straight out, because this file, when you build it up, it's still quite small, like 9 megs or whatever. You put your recorded session into it, especially if you've got yourself a high timer rate, you're going to have yourself a gig file instantly. And obviously the next time you want to do and play around with it, you're going to have to load yourself up a gig file. So do an export on it. Yeah, that's the best thing. So I think I've covered everything in this kind of walkthrough. I know, as usual, it's a little bit of a waffle. And the final thing I'm going to do personally as I'm here is just tidy this up, and I'll throw it all over the other side. Oh, I do miss my big screens. Let's bung that there, and I'm going to just take that off and bung that next to it. And I'll have it set up in such a way that you can start, well, you see the numbers, you just go delete from high to low if you start hitting performance issues. Hopefully you can run this. This runs, 8 Instruments runs really comfortably on my laptop, and hopefully now we've got the, we can have render audio on, so we can set our buffer sizes. We should be good to go. As I say, this will definitely be, I'm going to leave this default on -4. And you may need, I'm going to turn this down, so you may need to want to keep an eye on things, and you might need to increase that. So as I say, that's going to end this presentation, and all I'm going to do is kick off the start and see what's going to happen or not happen. When you added an instrument, I do find it's best to start things and then stop them. Oh, and yes, let's start the transport bar first. Something I always forget to do. And it, as I say, that really does help to keep everything in time, because we've got quite a lot of LFOs flying around. I do find I forget to turn it on, and when I'm using my ISO drivers and that, it actually sounds all right. Everything does stay in sync, because we've got this main pulse coming from one little LFO, which is keeping things in sync. But I found with my DX drivers, yeah, you can hear it. It definitely is going out, and I think that's probably, as well, yeah, DX drivers and sample rates and all the rest of it, they're all dodgy, I tell you. So yes, I'm waffling. Go! Go and download. Go and enjoy yourself. Let me know if it works or not. As I say, just the 2 paid devices. Oh, here's a big one. Actually, here is a big one. If you're on Windows, you're going to see in my download location, there's going to be a registry file you've got to run. You've got to make a registry setting. Basically, because of the amount of dual CV sources and everything else going on, I've blown the GDI object pool and you've got to increase it. I actually spoke to a dev, and I actually spoke to the dev who made this device, and he confirmed, yeah, I blew that, and he actually found the registry fix for me, and he's spoken to Reason, and Reason saying, yeah, they know about it and they're going to fix it in Reason 12 or whatever. Don't believe Mac users got any issues whatsoever, so let me know if you do have any issues on the Mac. I'm just going to quickly go over onto my other screen, and I closed it down, so let me pull something up and put it over here, and let's see if we can. I don't want that screen, I want, see, there's too many screens on my OBS screen. Can I bring this on here? No. Oh, it's being awkward. Oh, there we go, I've got it on, I've pulled it across. So this is what it's to do with this GDI objects. This is the key that you need to change. The default is 10,000. I'm running it 30,000. I think I set mine to. As I say, I will put in a link to this page so you can obviously read through this particular document. I'll also say I'm going to put a registry file up there, a .reg file, so for those who are not too au fait with making changes, obviously you can just double click on it. And I'll also put a default version, like a default GDI, so if you did have any issues, there'd be a default one there which should reset it back to what the default is usually in Windows, which is 10,000. As I say, you can obviously have a read through this about it all and why. So yeah, I nearly forgot about that. Let's see if I can get this off this screen onto this other one. You have to go fast, if not it catches. My mouse, if I drag on the screen, it's just stopped there because it wants to do funny things. Now, is that really it? That's the important one to make sure that, yeah, so that's the pay device. The sequence is the pay device. That reg file, yeah, then it'd be Bob's your uncle. Oh, is this going to work? I don't know if this is even going to work. You know, I'm going to click this button and it might not even work. And it really would help if I'm on the right screen. But the new instrument we wired in has worked. Well, I didn't know what sound it was. Gives you the phrase number. Even though it says countdown, this is the main timer at the moment because we've got -1. So when this gets to 1, it will open this up, and then we've got ourselves our LFO and our wait. At the moment, I've got the LFO slightly high, and you can see it's reset and everything's gone round. So we'll be on number 3. I will set this to 126. That's the highest you can set it to. You can individually, so that control there is changing all 8 of these. So you can individually change these weights. The higher they are, the fully it's set. So if this is fully up, you would wait indefinitely. And the further down it is, the more open it is. So you're going to go on. I know for a fact, looking at this figure, someone is behind. They're 1 step behind, which isn't a problem. We want people to be off different steps.